Lesson 1-7 is about multiplying rational numbers. Remember that rational numbers do include those integers, but also fractions, and they include decimals that either terminate or repeat. Now, when we see them in decimal form, we're only going to use terminating decimals. If they repeat, we need to change them back to fractions. We're using the same rules for multiplying integers to multiply rational numbers. So remember, if you have two numbers that are the same sign, when you multiply, the answer is always positive. If you have two numbers that are different signs, when you multiply, the product is negative. Example 1, we have 3.5 times negative 0.4. This means we have 3.5 groups of negative 0.4. And we could look at this on a number line. Since I'm using tenths, then I've broken my number line down into counting by tenths. So now I have 3 groups of negative 0.4. I need a half a group of negative 0.4, so I have to think of what is half of negative 0.4. Well, you might think of what's half of 4, that's 2. So half of negative 0.4 is negative 0.2. And then we arrive here just short of negative 1.5, which would be negative 1.4. So we could multiply decimals on a number line as we've just done, or we could just multiply the decimals and then notice that they're different signs, so your answer should be negative. So I'm going to write it out multiplying, ignoring the negative sign to start with. Remember when multiplying with decimals that we ignore the decimals first and just multiply. So we start with the 4. 4 times 5 is 20. Carry a 2. 4 times 3 is 12. Plus 2 is 14. And then we have a 0. I could multiply by 0, but what happens is I have to use a 0 placeholder. And then when I multiply 0 times 5, I get 0. When I multiply 0 times 3, I get 0 again. So when I add that row of zeros, I just have what I started with on my first row, 140. Then I have to think about the decimals. I have 1 digit behind the decimal in 3.5 to the right of the decimal. I have 1 digit to the right of the decimal in 0.4, so I should have 2 digits to the right of the decimal in my product. So 1.40, or we could write it with the negative in front since it should be a negative, and 1.4, and we could place a 0, but it's not necessary. It would mean the same. Example 2, we're multiplying fractions. Negative 5/6 times 2/5. And we have a couple ways we could approach this, and I don't mind which method you prefer to use of these two. I'm going to multiply my numerators first. Negative 5 times 2. And then I'm going to multiply my denominators. 6 times 5. I get negative 10 over 30. And we do need to reduce if it's possible. Those will both divide by 10 because they're both multiples of 10. They end in 0. So when I divide them both by 10, negative 10 divided by 10 is negative 1. 30 divided by 10 is 3. So I get negative 1/3. Or I could write it once again as negative 5 times 2 over 6 times 5. And at that point, I might notice some factors that both the numerator and denominator have in common. I notice that they both have a 5. So both of the 5s will divide by 5, so I end up with a negative 1 and a positive 1 here. I might also notice that 6 and 2 are both even numbers, so they divide by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So to clean that up, I've got negative 1 times 1 over 3 times 1, which results in negative 1 over 3. So I've got the same answer either way. Some students prefer to get rid of any common factors like we did in the second method, because usually you won't need to do any reducing at the end with that method. But either method is correct. Example 3, negative 0.3 times negative 11/30. Remember, if they are not both fractions or not both decimals, that we need to change one of the numbers so that they're both fractions or both terminating decimals. So I usually see if I can change them to both decimals first. So I could work that out by hand and use long division and say 11 divided by 30. I'm going to show you on the calculator. All it is dividing. 11 divided by 30 equal. And notice that the 6 repeats. So this is a repeating decimal, so I'm going to have to use fractions on this problem. So I'm going to change negative 0.3 to a fraction. We went over this in the previous unit. When changing a decimal to a fraction, everything in front of the decimal will be what goes in front of the fraction. In this case, it's just negative, so I'm going to include my negative sign. And then everything after the decimal is the numerator. That's 3. The place value of the last digit is the denominator. So 3 is in the tenths place. So I've got negative 3/10. It does not reduce any further. So it has been changed to a fraction, and I am ready to start multiplying these two fractions. I'm going to multiply the numerators, negative 3 times negative 11, and then multiply the denominators, 10 times 30. At this point, if you would like to reduce this by getting rid of any factors that both the numerator and denominator have in common, you can. I'm going to go ahead and multiply. A negative 3 times a negative 11 is a positive 33. And then 10 times 30, notice there's zeros. 1 times 3 is 3. And then there were 2 zeros in the factors, so it's 300. And this does need to reduce. So you might notice, or have already noticed, that they're both going to be able to divide by 3. So I'll go ahead and divide by 3 here. 33 divided by 3 is 11, and 300 divided by 3 is 100. So I've got 11 out of 100. If I wanted to see this as a decimal, it's already in a form that's easy to change to that. I could either divide on paper or on my calculator, or I could realize that the place value is 100, so this is 0.11, also called 11/100. Either form is correct to leave your answer. Okay, so it's your turn to try a couple problems. I want you to multiply each of these problems, and then go ahead and pause the video while you do this, and then come back in a little bit and check your answers. On our first problem, we have a decimal times a fraction. If they can both go to decimals, I would prefer that. So would 1/2 change to a decimal? Yes, it changes to the decimal 0.5, which is a terminating decimal, so we could use this. So 1.8 times negative 0.5. Then I'll notice I have a positive times a negative, so my answer is negative. And I could go to the side and work this out by hand, or I could go to a calculator, multiply 1.8 times 0.5, and I'll get 0.9. So it's negative 0.9. One thing I do want to note if you're using a calculator to do some of these computations, that's fine. You're welcome to use a calculator, but be careful about positive and negative numbers in a calculator. There are several different ways that a basic calculator will put those in, and it's really easy to make an error. So I would really just rely on your integer rules for positive and negative signs, and just use the calculator for doing the actual add, subtract, multiplying, and dividing. Our second problem, negative 3/4 times negative 2/3. I could rewrite my numerators, negative 3 times negative 2, and then my denominators, 4 times 3. Negative 3 times negative 2 is a positive 6, and then 4 times 3 is positive 12. And 6 over 12 will reduce. They'll both divide by 6. We get 1/2.